I'd love to introduce the wonderful, the fabulous, the amazing Ian Thomas, who's going to come up on the stage now. Here comes Ian. Ian's talking. Yeah, clap, clap, clap. Applause, applause, applause. Orchestration versus choreography. This sounds musical. It's not? It is. Okay. It sounds musical. Orchestration versus choreography.
Exactly. You're going to be disappointed, sorry.
Hey, thank you, Ian. Have fun.
Thank you. Hi, everybody, and welcome to my talk. I promise you to be as efficient as possible as the last talk of the day, because I know that everyone has had a lot to go into their head for the last 2 days. But yeah, it's quite dense, so I hope you get something out of it and enjoy it. To start, let's take a slight detour and talk about footballs. So I'm obviously from the UK. We love football. I'm a big Nottingham Forest fan for my sins. So the reason I put a football up on here is because I think there's some interesting correlation with software architecture. So footballs are made of many panels. Old style footballs, leather footballs, they were similar size and shape, but now more recently they're thermally bonded and they're made from a composite material. So they can be many different shapes and sizes, these panels. And they combine to make the ball round, give it great properties like speed of flight, more bend. They're really a modern marvel of technology. And this one in particular is the World Cup ball from last year. And this one's even more impressive because in the middle of it, it's got this sensor, and that samples at 500 times a second. It is looking for position on the pitch, how hard it's been kicked. It can help with refereeing decisions for offside. I think there was AI generation of graphics. It was awesome. Really, really incredible football. However, this isn't the reason that I think there's a parallel with technology. The real reason is more to do with when footballs get old. And if you are, like me, of a certain age, you may remember kicking a football around outside. It gets wet, and after a few years, it starts to deteriorate a bit. It might not be round anymore, but it still kind of fulfills the purpose. And if you want to keep playing with it, you know it's going to be okay, but it's probably going to need to be replaced at some point, or at least have some tender loving care. If you keep going, the stitching really starts to show at the edges. The bits that are combined together to make it round and work start to break up and fall apart. And as you can see here, the panels on the edges start to come away. And if you're not careful, this can lead to an all-out blowout, which looks a bit like this. And that could be an industry-wide outage for DNS in a company like the one I work at, or it could be something equally catastrophic for your business, or in the football terms, it means your game is over and you have to go home and tell your parents that you need a new football. So, detour over. Welcome to my talk. I'm a software engineer with Meta. I do lots of interesting things with VR and work, so if you're interested in that sort of thing, come and find me afterwards. This talk has nothing to do with that. It's more to do with architectural patterns to help you with delivering microservices in a microservices architecture. So, what's on the agenda today? There's a lot of talk around the patterns, but I think actually the fundamental thing is how we design our systems to enable change. And there's lots of things that go into change, not least complexity and coupling, but also how we design our organizations around the things that are going to be built and how we support them. So humans play a big role, state, data, failure, and the tooling and processes that we need to put in place also to help with the delivery of these systems. Someone who talks a lot about software evolution and change is a man called Lehman. He was a research professor at Imperial College London for many years, and before that he worked for IBM at Yorktown Heights in their research department. And he published a paper that was called Programs, Life Cycles and Laws of Software Evolution. And this talked about his 8 laws of how software needs to evolve and why it evolves. So I'm not going to go through all 8, but there's 4 in particular that I think are really interesting. And they're these 4. And they're interesting for a variety of reasons, not least the complexity one at the top right. But the one I'd call out for you right now is quality at the bottom left. And the reason I call that out is because when we think of quality, it's normally about what we put into the system. But this particular law is focused more on the things that change around us. So if we deployed something, we deployed an application, and just left it, it's going to rot. The world moves on, software moves on, security moves on, the ecosystem that we build as part of moves on. So we need to keep evolving our systems to maintain a level of quality perceived by our users based on things that are changing outside. And that's another different way of looking at these laws. So I've colored these differently. So there's one side, the orange side, which is change in the outside world that drives a need for change within our software. And then there's the purple side, which is change in the system itself drives a need for us to adapt and evolve our software. And two really interesting ones here that there's been a lot of talks at the conference that would back this up. They relate to the kind of the social aspects of a socio-technical system and how organizations and people need to be organized around the software to maintain familiarity and mastery of the software. It's one of the first references I've seen to reducing cognitive load and the impact that has on how we deliver software. In his paper, he's got an example showing how, over time, over a number of years, the size of a system gradually reduced the rate of growth of features in that system. And he demonstrably says this is down to the second law, which is the growing complexity. So complexity is clearly a big problem for us as software architects. When we think about microservices, you often think this is about scaling. And that's not just scaling from a technical perspective, that's also we want to scale our business, we want to be able to do more. So the theory goes that if you add more people, we get faster and we do more stuff. But I think in reality, what you tend to see is something that looks a bit more like this, whereas the head count goes up linearly, the feature delivery flattens out. And I was glad to see that earlier in the conference that someone else was calling this out as well, just to take a note which one of these is actually more relevant to your situation. But if you're here early, you might recognize this graph, which is very similar. So it's nice to know that there's someone else thinking in a similar vein to me. So orchestration and choreography, they're there to support this concept of workflows. But what is a workflow? It wouldn't be an architecture presentation without the canonical e-commerce checkout flow. And this is my crude version of some sort of architecture diagram to show exactly the states and transitions that go between them. And the thing that I want to call out here, as we're thinking about this going forward, is there are different ways to consider the lines and the boxes that make up this diagram. So here I've called out the happy path, which is across the top. You place the order, check the stock, it gets paid for and then shipped and off you go. But there's also a need to acknowledge that there's going to be some failures along the way, and there might be some time that you have to pause. Not least if you get to the end where the product is shipped and then it never turns up and you end up in the abyss of product support and shipping support. We can draw boxes around these states and we can roughly align them with a domain, and this is a nice way of starting to think about how we could carve up our systems to support growth and individual ownership of teams. And to help just sort of clarify what these blobs mean, just to go through a quick DDD refresher, because again, DDD, it's a theme of the conference. These blobs are our domains. They're our bounded contexts. They are a consistent model that we have for our domain, where everybody from any type of part of the business, marketing, finance, technology, product, they agree what words mean. And that's the ubiquitous language that we use. Inside those bounded contexts, one thing that I want to clear up is that it doesn't mean one microservice per bounded context. You can have many. There's no reason that you wouldn't have several in there. And that's where concepts like subdomains come in to help you further subdivide your bounded context to make it more manageable from a team's ownership perspective. And then lastly, the thing that I care about, and you'll see me talking about a lot in this talk, is the concept of the transfer of data between bounded contexts. And that's this interchange context that exists between the boxes. And this is really critical because this is an often you underthink what you need to do to support data being shared between services and systems. Zooming back out to our workflow, another way of looking at this that we'll come back to is whether a transfer of state is internal to your bounded context or external. And this helps with some of the decision making about which sort of pattern you might want to choose, which leads me nicely into the interaction patterns themselves. So we'll start with orchestration. So orchestration is perhaps a little simpler of the two. It's conceptually one service that acts as a coordinator, a mediator, that will take requests and it will organize further calls to other APIs to manage a workflow throughout the life cycle of it. An oversimplification, and perhaps a little bit naively, that's often thought about as a synchronous thing, but as you saw in the checkout flow, there are pauses there where things have to wait for people to do stuff. So it's not always synchronous. Maybe the calls are more likely to be request-response, but they're not exclusively request-response. One thing to note here is that they are a little latency sensitive if they are request-response. And if you do get failures, then it tends to cascade, scale cascades, because it's more coupled. Of course, it's never that simple, and what you might find is that you have a workflow that has a well-defined orchestrator at the start of it, but then the software you build to support it and the services that you build become ad hoc orchestrators themselves. And a good example of this is from when I was working for PokerStars, and we were building a back-end for front-end system where we were building kind of like a buffer between our iOS and our web clients and our back-end systems. And they become unofficial orchestrators. So yeah, look away now if you're allergic to UML. So you can see here we're going to talk to 3 different systems, and we need to understand how those systems are going to interact with us. Maybe a slightly better view of this is to think of it a bit more like a flow chart and call out a couple of the components that exist within our system. So here you can see a request comes in, and the idea of this endpoint is that it's going to return all the lists of football matches that are happening in the Premier League in the next 7 days, and it's going to tell you the prices of the match result market, win, draw, win for that game, and show it on page. So you can see here we've got all these various calls in. Some can be parallel. Others have to wait for the response from other calls to provide the input. And 2 things I wanted to call out here. One is I haven't modeled any kind of failure paths, which as you add calls into this sort of thing, obviously they explode exponentially. But the other thing to think about is the services on the right aren't owned by the team that built the thing on the left. So when we have a client, as we have here for the CMS, the catalog and pricing system, who owns that and who manages the change and who coordinates the change between those clients and the services that are existing elsewhere? It's an important part of the consideration of how you design things and how you design your organization. I mentioned before that we need to consider human-in-the-loop workflows. And I think a really good example of that we perhaps don't think about very often in this sense is the dev lifecycle. And this is a great example of how people and automation often combine to achieve an end result. And you can see here, I've got a few different things in. Your mileage might vary. I'm sure people have got different processes to this. But you can see there are parts where we're waiting on somebody to do something like merge the PR or deploy to production. But there are periods where we can do things automatically and push out data to staging environments, run tests, linting, all that kind of stuff. If we go back to the original example, one of the nice things that an orchestration approach gives you is that if something goes wrong, it's easier to coordinate the unwinding of transactions and unwinding of effort, because you've got this state in the middle that knows what's been done, and it can then perform the compensatory actions to get you back into a good state. It's a nice way of thinking that actually we've got some simple understanding of the end-to-end workflow. So complexity, especially for longer workflows, this is a better way of thinking about managing how you handle those error states. And if we think back to talking about request response being the primary interaction paradigm between the orchestrator and the systems, then we've got loads of prior art there to help us handle failure in that regard. So I've heard mentioned today of things like circuit breakers, retries, health checks, and bulkheads, that sort of thing. These are all elements that are increasingly common and are more often than not now pushed to your platform. So you get them for free. This is stuff that you can kind of just assume is there, especially if you've got a decent service mesh implementation. The last thing I want to say about orchestration is that if you can, it's better to have an orchestrator per workflow rather than share orchestrators for many workflows, just to help with isolation of failure and help with the evolving nature of those different workflows together. That doesn't mean that they're restricted to only operating with a certain set of services. They can all kind of overlap and use them as they need to. So in summary, some of the pros and cons of orchestration are, it's great if you want to have a complicated workflow where you've got state that you want to be able to query and understand. And if you've got some complex error handling situations or something that's quite business critical, that single source of truth is a useful way of thinking about building a system out, because you can understand the ways that you can manage the failure. On the other side of it, though, that single point of failure does mean that if that thing goes wrong, or if one of the points in that system goes wrong, then you are going to have a reliability issue. And you might find that because of the way that the systems interact with request response, if you're using that paradigm, there's additional latency, some scalability issues, and it might not be as responsive. So, choreography, what's the difference? Mainly, it's that there's nothing coordinating it. And that's basically a brilliant thing if you want to have lots of independent stuff going on. but perhaps a little bit of a compromise if you want to have some way of understanding how to roll back in terms of failure. At its most basic level, you can see here that you've got these contexts that they do stuff and they just chuck out events saying this happened, and then other people who may or may not be known to the original producer listen to those events and then perform work based on them. So there's an asynchronous element to this. There's probably some intermediate infrastructure required. There are ways to avoid that, but that tends to be the best way of building things. And you get all sorts of benefits, like it's much more scalable, you can use different technology stacks, and you have less latency sensitivity. Again, no, it's not always that simple. There's not just 3 things in there. And you might find that over time, as events grow and a number of events in your system expand, that things happen that you probably weren't expecting. And it's not beyond the realms of imagination to think here that if the wrong event gets emitted at the wrong time, you could start up an infinite loop and your systems will go crazy, which means that there's a few things you need to consider around control planes, which we'll touch on later. When you're choosing these systems, you can make a choice between events and commands. If you're not familiar with the two, one is basically telling somebody to do something, whereas the other one is a statement of fact. And I tend to think that I'd prefer to use events over commands, but it's not a hard and fast rule, because it's easier to think about saying something's happened and having an unknown number of consumers being able to work with that, rather than putting the burden of knowledge on the producer to say, right, I explicitly want this to happen in this system. But there are some gotchas with events too, not least that you don't want to have multiple producers of the same event saying something, and you definitely don't want to have the same event rebroadcast by different services. Events come in different categories, and Martin Fowler has a really good write-up about this that sort of helps to decide between what kind of behaviors you want from your events. So starting at the top, you've got this sort of notification pattern, where this is a very lightweight message that says something happened. You may need to act on it, you may not. If you do act on it, the chances are you might need to go back to the source system and request more information. To get around that, if you want to reduce the chattiness, you can use the event-carried state transfer approach, which is the most catchy name ever. And that will help you because you put more data in your event. So there's more stuff flowing across the network, but it might mean that you can build up a picture of the state you need in your service without having to call back to the source, which is a reasonably nice property. Those first two tend to be produced in a system where events are consumed and then they go away. A way to sort of build on that is to think about things being durable, and event sourcing is that kind of model where you would use a durable log. Events get pushed into it, records get pushed into it. They're there for a known amount of time that you can determine yourself, like what your retention length is going to be. And that gives you really nice properties around being able to replay and reconstruct state at any time in the future if your system goes bad or you need to bring up a beta test of something and just check it gets to the same point as the original system that you were building. The last one, CQRS, I'm not really going to touch on this too much because it's a case of it's good to know about, but it's perhaps one to handle with caution, because while it offers some really good benefits, like you can have multiple ways of deciding how you're going to use the data, you can build different read paths for it to the write paths, things can get complicated quite quickly, and it might be something that if you are going to use it, you go and investigate in a little bit more depth than perhaps I've got time to cover right now. So with that all said, let's have a think about some of the messaging patterns, because again, it's not just we'll chuck this out into the world and be done with it. There's obviously different things to consider in terms of the way that our systems are going to work with them, and the patterns in our messaging systems can have interesting properties, but also interesting gotchas too. So I'm going to just quickly whip through a few of the different ways that we've built stuff in the past. This is an AMQP-based system. And the different types of things you have to consider here are things like, what type of exchange am I going to want to use? How are my consumers going to say what type of data I'm interested in? So in this direct exchange example, they have an explicit routing key that they will ask for, and they will get all the messages related to that routing key, which is nice. But one thing to consider here is if we want to scale our consumers, that would typically lead you to have more of a round-robin approach. So you lose certain properties like ordering and guarantees around what gets processed in what sort of sequence. But it does allow you to have things like a worker pool. So if you're not sensitive to ordering, this is a great way of scaling things. Fan-out exchanges, they ignore routing keys entirely and just farm everything to everybody, which is also really useful, but has some things to consider in terms of the size of the messages you're sending. This can quickly saturate your network, and if you're not careful, you might be sending more data than you really want to. And the last one is a topic exchange, where you can subscribe to things and you can give different kind of patterns that say, yes, I'll have everything to do with the user, please, or no, I want to be really specific. I only want to know when the account's open. This is an attractive way of building software because you think this is nice. But one of the subtle problems with this that I've seen over time is that because you can subscribe to a broad range of things, if you have a particularly high cardinality of the schema types of things that you're publishing to this exchange, for example, all of the user events might be many, it might be hundreds, changing those schemas could lead to some unexpected side effects where people are coupled to a certain version and they break, or you see other nasty kind of coupling where people are wanting something, adding, and then it ripples out and you're sending lots of information to everybody that didn't really want it in the first place. On the durable log side of things, Kafka's probably the best known example of that. And this is different because you don't have many queues bound to an exchange and copying data. You write it once, and that's the burden of that is knowledge on the producer. So it will write to a partition within a topic, and then consumers are assigned a partition to consume from, which is really cool because you can see how you can scale up your consumers, and you don't lose any of the ordering guarantees because your order, the data is stored securely in a partition, and it's ordered and will remain ordered for the duration of time that it's retained. The good thing about this, obviously, is that you can scale it quite well. However, you do have to plan ahead because if you get the wrong number of partitions and you suddenly find you have a much higher throughput than you were expecting, then changing the number of partitions will change the way that your data is routed to them. And you might find that some of the scaling properties that you came to rely on before, just thinking back to Mike Nygaard's talk before with Hiram's law, some of the ordering properties that you're working on before are no longer guaranteed, at least until all the data is played through. You can see here that the consumers are grouped together, and those groups are a nice way of being able to have separate sets of consumers that all work independently of each other. And because the data is persisted once and you're not duplicating it everywhere, having many types of consumer groups is not going to be a penalty for you. And they can consume it independently of each other. There's no kind of penalty for going slower or faster. The only thing to consider is if you're going too slow and the retention period is going to be catching data and removing it before you've actually processed it, then you've got some other issues. So some considerations I've touched on here, message size, infinite loops, maybe needing some extra infrastructure, the delivery semantics and things like that. One notable exception here that I didn't talk about was how you would handle workflow level activity. So before in the orchestrator, if something went wrong, you could see that orchestrator is able to unwind, or if there was a need for a global timeout, you could put that in the orchestrator and you could define it in your workflow. With choreography, it's less capable of doing that. And you can see here, if you imagine that you wanted to cancel that order, the way that you would manage that is something's going to have to know how to send events through this system to unpick all of the state that may be generated. And while this is a very trivial 4 or 5 state kind of thing, when you have a real system with lots of different services all talking to each other with events, then all of a sudden you find that this problem becomes quite an issue. And so it's where you have to be really careful to consider, like, what is the business criticality of the workflow that we're building, and how much complexity is there in the error handling that we want to manage. So in summary, choreography, it's great because there's weaker coupling, but on the other hand, it does get quite complicated quite quickly, and I think event-driven architectures in general, they've been quite a buzz recently, and everyone's sort of pushing in that direction. I know AWS are making an awful lot of noise about going after an EDA, but it's handle with care, buyer beware sort of thing, because there are lots of things here that if you don't understand them ahead of time, which I know that we all hate to think about doing big upfront design, but if you don't think about them enough ahead of time, you're going to be bitten, and you can be bitten in quite horrible ways that are hard to get out of. Other things that are great about choreography is you can get really high throughput. There's lots of wonderful things around scalability and responsiveness. But again, that lack of single view of state of the workflow and no ability to kind of version it end to end and codify it in some way is something to beware of. So with all that said and all these patterns discussed, how do we go about choosing them? And there's some advice on the internet that's been sort of widely shared by Yan Choi that says use orchestration within the bounded context of a microservice, but use choreography between the bounded contexts. And I'm afraid to say that I'm not 100% in agreement with this, because if we go back to our diagram where we had the external, internal stuff, if I'm trying to manage something that's business critical, and I'm going to put events between the bounded context, but then I know I need to unwind stuff if I've got an order that needs cancelling, or some other thing in your world, a trade that needs to be changed in some way. I'd rather do that in a more secure, synchronous fashion using a request-response paradigm than I would with events, because I can guarantee it's going to happen. I can follow that state change through. But it's not the worst advice in the world, and obviously it depends is a classic thing to say here, because you might find that there are times where the workflow is not particularly complicated and actually the events are a good idea. I have also seen, having worked on sports betting platforms for a number of years, really successful use of choreography within bounded context, especially in processing trading data and real-time data. That event-driven systems there are a brilliant idea, and they work really well, and they are excellent because you would tend to have one team owning all the components in that streaming service, and that makes it a lot more secure. You have a greater chance of understanding exactly what's going on within that workflow and managing the change that you need to put in there. Thinking about how we'd specify what's happening in our workflows, there's a spectrum here as well. So if we go from the far left where something is very formally specified, think something like AWS step functions here, where you can use their JSON format to say exactly these are all the steps that I want to have here, these are all the different lambdas that are going to get called, this is what I want to happen when it fails, this is what I want to happen when it passes. That's a really great way. You can specify it, or you can version control it, you can stick it into documentation. I think there's even now ways that you can build this with a visual editor as well. That far end is brilliant. Lots of great things there. As you go across towards the choreography side, this is where you start to see the more ad hoc implementations like I spoke about before, where we built the back end for front end. And as you go more towards the far right, which is traditional event-driven architecture territory, it's not unrealistic that nobody really knows how it works, and actually it's probably just in a couple of people's heads, and if they leave the business, you might be in a bit of trouble. Thinking about what these workflows mean and what a bounded context might represent, you need to consider how the coupling of these things are going to bear out on you, and there is a need for coupling. Our systems are useless if they are not coupled in some way, and a domain has a necessary amount of coupling within it. However, as software engineers and architects, we can't make that better, we can only make it worse. And what you find with that is, if I can reappropriate Fred Brooks' essential and accidental complexity, you get the essential coupling and you get the accidental stuff. And the essential stuff is the things that you have to do. When you place an order, you're going to need to take some money, and you're going to need to say, is this stock available? Am I able to fulfill it? Can I get it to the shipping service? Does the warehouse know what to pick? But you can 100% have a lot of coupling added accidentally, mainly because you might not have thought about all the ways that things are going to interact with each other, or you haven't had a more rigorous design process, you haven't been deliberate in planning it out, you've just had a go and stuck something into your production system, and it's grown over time, and there's been no kind of deliberate stewardship of it. And that's where problems can really come about. And I think this is where I have a bit of a problem with some of the agile work that I've done in the past with teams, where they don't want to consider things and planning and do high-level designs, because we'll just try it out in production. But some of this stuff, they can be one-way doors if you're not careful, and you've got to be very, very deliberate in making sure that you avoid them wherever possible. Mike Nygaard, again, he was on stage just now. I really like his framing of types of coupling from his talk, Uncoupling. And I'm in particular, you could probably guess, I'm really interested in the bottom one, which is incidental coupling, which is where stuff changes and you don't really know why it's got to. And that's kind of leading into some of the issues that you have with some of these event-driven architectures, where you're not necessarily sure kind of what's going on across the whole state of the system. And this sort of thing, this kind of coupling, the incidental coupling might happen in ways that you're perhaps not expecting. And one that I would bring to your attention is this board that popped up when I was working for Skybet back in 2018. Now, what this represents is a matrix of all the different engineering squads that we'd created over the previous sort of 12 months as we went about splitting up from one bigger dev team into many smaller teams that owned discrete areas. And what we noticed was the delivery team had obviously found a problem where teams were not able to progress without asking other teams to do work on their behalf. And so they put this board up to help us visualize that work because it was getting hard to track it. And you can see here, this is pretty early days in this. There's not much on there, but I can guarantee you a couple of weeks later, it was covered in stickies. There is absolutely tons of dependencies there. And it's not the sort of stuff that you might have seen from these definitions before. The sort of things you'd seen from the definitions before, because not all of them require development changes. Some of them were just permissions changes or asking people for their advice on things and waiting for them to have time in their calendar to actually come and engage with us. So that type of coupling is quite nefarious. And just to really highlight this, I love this example from Dominica de Grandis, which is she talks about what's happening, what the chances are of you being seated on time if you go to a restaurant with a friend. And the concept is if you're not there on time, you will not be seated. So if you're both there on time, brilliant, you're in. The other person doesn't get there on time, or you don't, or you're both late, that's it, you're not in. So you've got a 1 in 4 chance. Add a third person into this, and it goes from 1 in 4 to 1 in 8, or 12.5% chance of being seated. And as you add stuff into this, as you add dependencies, that chance of being seated trends to 0. And if you're particularly interested in the maths, it's not particularly complicated. It's 1 over 2 to the n. And more visually, it's more striking that as your dependencies increase, it very, very quickly trends to 0. Because you can see here at 6 dependencies, you've got a 1.6% chance of everything happening just as you want it to. 10, and you're down to 0.1%. So very quickly, dependencies are quite detrimental to your chances of success. So coupling is something to be very wary of indeed. So I'm going to add a sixth one on the bottom here to Mike's list, which is organizational, where you can only make progress through others. And that doesn't necessarily mean the same thing as development up there, where producers and consumers have to change at the same time. It could entirely be approvals, it could be asking for advice, it could be anything that doesn't result in everyone changing their systems. It just means that you're blocked until they have had some input in some way. The last thing here is this often comes up in the light of people discussing decomposition and taking their monolith and carving it up into microservices. And I think, without laboring this point about coupling too much, decomposition definitely doesn't equal decoupling. And you have to be extremely deliberate in the way that you do your decomposition, because if you're not careful, you end up in a much worse state, because there's an awful lot of considerations around distributed systems that make life much worse for you than if you just stuck with something that was, admittedly, maybe a bit of a ball of mud, but it was together and it was understandable in one cohesive unit. So, to sum up, I would summarize that the value of orchestration, it increases with the complexity of your workflow. And that's especially true when you've got complicated error scenarios. It's great because you can be very deliberate and define your workflows and you can understand what's going on, you can manage it. Whereas, if you have higher responsiveness and scalability requirements, there's not too much of a link between your systems and you want to have a greater deal of independence. Choreography is a really nice way of going in that regard. And if you have your cameras ready, I'll put all that stuff onto one massive slide and I'll wander out of the way so you can take a shot if you want. Cool, so with all that said, how do we make this work? What do we need to do to be successful? Because I've been the doomsayer for enough of this talk. Like, what are the things we can put in place to make it much more efficient and we can be more confident of success? I know that Simon Brown's at the conference, so he'll be clamoring to take a photo of this because it's an awful architecture diagram that I know he's particularly not fond of. But this kind of helps to highlight the issue and think about something as an end-to-end workflow in a more realistic situation where you've got different bounded contexts, a bit of orchestration going on, a bit of choreography because you've got events in there, and lots of things happening. When we look at this, I tend to look at it in two lights, like what's going to be inside those boxes? Well, how do we build these things to be successful? And I think there's a great post from Confluent from a few years back that talks about the 4 pillars of streaming capabilities. And I think these 4 pillars, forget the streaming part, these are excellent to have in mind for any kind of system. And the things that they talk about here that are really critical are things like the control plane, because especially in event-driven systems, they're often a bit of an afterthought. These streaming systems are going to keep processing stuff no matter what happens. So if you haven't built in a way to stop it, they're just going to keep chugging on, and they're going to make the situation worse and worse and worse. So ahead of time thinking about how am I going to manage the life cycle of this system so I can leave it running and inspect it and triage the state of it without turning it off. Like, give yourself some leverage to have some levers and knobs to pull and turn. Instrumentation and the operational plane, obviously they go without saying now. It's much more widely covered in the industry. And the only other thing to sort of note in here is that event-driven systems do have some quirks about them that make them a little bit more tricky to implement things like the control plane, but it's not impossible and it's getting better all the time. Looking at the diagram again and thinking about, you've got your boxes and lines, the bits between the boxes are where I have a particular hobby horse, and I tend to rant about this quite a lot with people in different companies and at the pub. And that's because I ask people to think, like, what does this line actually mean? What does it represent? And when you start to dig into it, there's all sorts of technical things in there that you have to consider, like what's the DNS, the connectivity, like the certificates. Are there any data format issues or authentication, secrets to manage, that kind of thing, schemas? And one of the ones that often is in there that you don't think about is the physical connection. And again, this is an example from back when I was at Skybet. You don't think about this at all, but we had this incident back in 2016 where a boat dropped an anchor in the English Channel, and because of the ways that we were licensed, we had all of our data centers in Guernsey, and this boat's anchor severed 3 of the 4 internet connections to the Channel Islands. So we were very, very close to complete outages and losing all of our ability to service customer traffic, which for a betting company where people are placing money and there are transactions and there's financial stuff on the line, that was not a good system, not a good situation for us to be in at all. So the physical connection is definitely something that I think people perhaps need to bear a bit more in mind than they perhaps often do. Layer on top of that, you've got all of the social aspects too, and that line represents change management processes, scrum of scrums, people going and presenting at change advisory boards to get things permissions. There's a lot to consider here. That line's holding an awful lot of weight. So there's quite a big emphasis on thinking about this stuff up front. Like, if you don't deliberately consider it, then you're going to be having some issues. So when you're thinking about these architectures and putting these patterns in place, I'd sort of challenge you to think, like, well, how are you going to handle testing it end-to-end? How are you going to handle when things fail? How are you going to handle the case where you've got data loss? How are you going to go about making sure you've got teams that can handle owning this thing long-term? What's the scheme evolution and what's the serialization format? And how do we avoid some of the pitfalls of accidental coupling? Scheme evolution is one of those topics that I'm especially hobby-horsey about, and that is because I've been bitten by this many, many times in the past, where you haven't given enough thought to what your schema compatibility guarantees are, and you change stuff, and all of a sudden you've poked yourself in the eye in a really bad way. So again, referencing Confluent, because they've got some really good docs on this, think about the guarantees that you want to have when you're designing the data that's going to be going into your systems. And many people will be instinctively reaching, well, I want to have full backwards compatibility. I want to have forward transition. It's always a case of understanding the trade-offs, because there are things that you can do with some scenarios that make it nice and straightforward to evolve over time, and there are too many guarantees. If you go for full compatibility, then it can be quite restrictive, and it limits your options longer term. Some of the technologies that we've got to help us in our delivery of these sort of systems include PACTs, which I think has been mentioned earlier today as well. For contract testing, you've got things like OpenAPI, Avro, and Thrift, which is a great way of thinking about kind of serializing data and protobufs. But also you've got tools coming out now that are really helpful, because OpenAPI and Swagger have been fairly revolutionary in terms of handling testing and management of request response APIs. But async API is a similar initiative for event-driven systems as well, to help you with that kind of schematization and understanding of what's exactly going to be happening across your system. And then other things to call out here are things like OpenTelemetry. And if you do want to explore orchestration in a bit more depth, then all 3 of AWS, Azure, and Google GCP have got excellent products that you can experiment with too. So, with 4 minutes left on the clock, what are the key takeaways that I've got from this talk for you, other than the terrible English puns about takeaway shops? Number 1, Favor orchestration when you have a complicated workflow, especially when you have a complicated workflow that has significant complexity in the error handling. Whereas choreography is a really good way of thinking about systems that require lots of scalability, high reliability, responsiveness, and they don't require, there's not so much of a problem if they are more weakly coupled. Enable the long-term changeability of your systems by being deliberate when you're thinking about designing them, because it's too easy to just sort of get going and then realize 6 months, 12 months down the line that some of the things that you were doing have left you in a corner that it's very hard to engineer your way out of. The longer-term health of your systems would behoove you to have a bit more time just to make sure that you're thinking of doing the right thing up front. And putting in the effort, as with many Lehman's laws, to manage things like complexity and to keep up with the changes in the ecosystem around you. And the last thing, complexity breeds in the bits between the boxes, and that is something that I think we all need to keep in mind when we're just casually sketching things on whiteboards. Handle that with care and make sure you do not forget about the people in that system too. And with that, thank you very much for your attention. Hope you enjoyed the conference.
Woo! Thank you, Ian. We do have time for a couple of questions. Do we have questions, Slido people? Yeah? Yeah, okay, cool. I'm going to read them. You're going to answer them. There's only one. Nicholas says, can you bring that big diagram about orchestration versus choreography and comparing the two?
Yeah.
Oh, yeah, this one?
That one?
It is a big diagram. Oh, people are taking pictures. Oh, okay, take your pictures.
I'm going to take a picture.
Ian, is there somewhere they can get the slide? Like, do you share it publicly?
I'll make them available to download afterwards, for sure, yeah.
Okay, he'll share it publicly. Now he's taking a photo of you taking a photo.
Yeah.
That's meta.
You were here. You can prove to your boss that you were here. Last thing on a Friday.
Any more Slido? No Slido. Okay, that's okay. Bana, am I on time? Where's Bana? Yes! So, Ian, thank you so much.
Thank you.
This is yours.
Thank you very much.
We have to look into the camera when we give it.